Good day class, so for today's lesson, we will discuss Module 1, Exogenous Processes of Earth. At the end of this module, you will be able to describe how rocks undergo weathering, explain how the products of weathering are carried away by erosion and deposited elsewhere, explain how rocks and soil move down slope due to the direct action of gravity. Exogenous processes. The geological processes of Earth describe the natural forces that influence the shape and structure of the planet. Plate tectonics, erosions, weathering, and sedimentations are among examples of forces that significantly affects Earth's surfaces. These processes are continuously studied by geologists and other scientists to expand their ideas of how Earth evolved to what it is today, to locate useful resources that can be used in human civilization, and to improve their knowledge on potential disastrous events caused by various hazards from these processes and activities. The dynamism of Earth, attributed to its never-ending geologic processes, is driven by internal and external forces on Earth. Thus, geologic processes are broken down into two categories: the exogenous or the external processes and the endogenous or the internal processes. In addition, Earth is an oblate spheroid in shape. This means that it is spherical in shape, but not perfectly round. In relation, exogenous processes shape the Earth by means of disintegration of rocks and chemical transportation, whether it is in physical and chemical changes. In the structures of our planet Earth, exogenous is very essential. Geologists describes and studies the structures of the Earth and the processes that have shaped the structures of the Earth. Geology provides the primary evidence for plate tectonics, the evolutionary history of life, and the past climate change. Big idea. Earth's structure is naturally altered by internal endogenous and external exogenous natural forces. Since humans are part of Earth's system, they are not spared from the effects of these geological changes. So this explains that endogenous and exogenous processes are natural forces of nature that cannot be stopped. So humans should adapt these changes also, because they are part of the Earth system, and we as humans should be prepared in these changes, most especially in times of natural disasters. The exogenous processes occur on or near the surface of the Earth. These are natural occurrences that leave significant changes on the landscape and even in the ecosystem of an area. In some cases, exogenous can wipe out the majority of the organism inhabiting that region. Another example is in terms of weathering, like long drought or El Niño phenomenon. El Niño reduces the water in a certain place because of long duration of intense heat with no rain. When this happens, organisms die. For example, organisms living in the oceans or rivers, resulting to massive wipeout of different species, including fishes. There are types of exogenous processes. The first one, we have weathering. It is the disintegration of rocks soils and minerals together with other materials through contact with Earth subsystems. Weathering happens even without movement or transportation, as opposed to erosion that involves movement. So the material involved in weathering should be in static position. There is no movement involved. The breaking down of soils and rocks happens on the spot. Two important types of weathering exist. So in addition, weathering describes the breaking down or dissolving of rocks. That means disintegration. And the minerals on the surface of the earth. Water, ice, acids, salts, plants, animals, and changes in temperature are all agents of weathering. Once a rock has been broken down, a process called erosion transports the bits of rock and mineral away. Weathering is important because it produces unconsolidated material, or the parent material, from which soil is formed, results in the formation of secondary minerals, the most important group being the clay minerals. Smaller rocks are weathered to the mineral that make up the rocks. So we have the physical weathering. Physical weathering is the breaking down of rocks by mechanical forces, concentrated along rock fractures. These can occur due to changes, whether sudden or not, in temperature, pressure, frost, etc. For example, soils crack because of extreme heat or drought. In some cases, water, wind, or ice may abrade or scrape rocks or soils through its tremendous cutting power. So, in addition, physical weathering is caused by effects of changing temperature on rocks, causing the rock to break apart. The process is sometimes assisted by water. So we have the first type of physical weathering, the exfoliation. So exfoliation is a form of physical weathering in which curved plates of rock are stripped from rock below. This results in exfoliation domes or dome-like hills and rounded boulders. Exfoliation domes occur along planes of parting called joints, which are curved or more or less parallel to the surface. In addition, it is also called unloading, which is when outer layers of rock break away from the rest of the rock. Next, we have abrasion. Abrasion is when moving material causes rock to break into smaller rocks. We have the two types of abrasion. Water abrasion, causes by the forces of water along rivers and streams. We have also the wind abrasion. It is commonly happen when the wind or the intense wind breaks the rocks into smaller particles. Next, we have the thermal expansion. Thermal expansion is another type of physical weathering that occurs mainly in desert areas, like those shown in a Sahara Desert. The outer layer of the rock is heated by the sun, which causes it to expand, and as it cools during the night, it contracts. Next, we have the frost wedging. Frost wedging is a form of physical weathering that involves the physical breaking of the rock the repeated freezing and thawing of water found in the cracks of rocks, called joints. This pushes the rock to the breaking point. When the crack reaches a certain depth, the rock will physically break apart. So we have another type of weathering. We have the chemical weathering. Chemical weathering is the process by which rocks break down by chemical reactions, while physical changes happen on rocks during physical weathering. New or secondary minerals develop and sometimes replace the original properties of the minerals in the original rock or soil during chemical weathering. Oxidation and hydrolysis are chemical processes that contributed to these changes. For instances, the presence of water and oxygen in the biological decomposition of microbial action in rocks may cause them to disintegrate. So, we will explain further what is oxidation. Oxidation is another kind of chemical weathering that occurs when oxygen combines with another substance and creates compounds called oxides. When rocks, particularly those with iron in them, are exposed to air and water, the iron undergoes oxidation process, which can weaken the rocks and make them crumble. The product of this type of oxidation will result to rusting, as you can see in our image. Next, we have the hydrolysis. So hydrolysis takes place when acid rain reacts with rock-forming minerals, such as feldspar, to produce clay and salts that are removed in solution. The only common rock-forming mineral that is not affected is quartz, which is a chemically resistant mineral. New types of rocks are created because of weathering. In fact, both types of weathering contributed to the formation of new rocks. For example, granite, which is an intrusive igneous rock, may undergo physical weathering from fracturing due to temperature and pressure changes in the surroundings. Then, when acid rain falls on it, chemical weathering occurs when granite reacts with carbon or carbonic acid from acid rain to form a new rock called kaolinite, a clay mineral. In addition, kaolinite, also called China clay, soft white clay, as you can see in our image, that is an essential ingredient in the manufacturing of China porcelain, and it is widely used in the making of paper, rubber, paint, and many more products. Kaolinite is named after the hill in China, Kaolin, from which it was mined for centuries. Next type of exogenous processes, we have erosion. Erosion is the process by which Earth's surface is worn away by wind, water, or ice. So it involves movement. The process of erosion moves rock debris or soil from one place to another. Erosion takes place When there is rainfall, surface runoff, flowing river, seawater intrusion, flooding, freezing, thawing, hurricane, wind, etc. These are forces of nature, whether violent or passive, capable of exfoliating and scraping the surface and exposing the layers underneath it. Movement of land animals during migration or stampede can also cause erosion. In addition, numerous human activities also cause soil erosion, such as deforestation, or simply means cutting of trees for fuel and wood for structures and other objects. We have also overgrazing of farm animals and urbanization. Sometimes erosion can cause massive deterioration and destruction of surface structure and foundation, which may become critical in the safety of buildings and communities, most likely to happen during natural disasters like earthquakes. So in addition, erosion is the process of soil, rock, and other particles displacing from a location by wind and or by water, like stormwater runoff or flash flood. Erosion affects wildlife, public and private property, and contributes to pollution. So erosion and sediment control is very important. Next, we have mass wasting. It is the movement of material on a downslope terrain due to gravity. Mass wasting usually happens in slope, is dangerous, and may occur in areas that can trigger mass movement. The critical areas may have increased water flow, such as rainfall or flash floods, steep slopes, scarce or no vegetation, or vibrating or moving ground from earthquakes or industrial activities, for example. Another examples that can cause mass wasting is deforestation. Deforestation can cause mass wasting after trees are removed. This is particularly bad in the tropical rainforests, as the topsoil washes away quickly and takes a long time to regrow. The impact of mass movement or mass wasting increases as pollution grows and cities expand into unstable areas. We have types of mass wasting. The first one, we have debris flow. Debris flow happens when a large amount of sediments, usually rocks of various sizes, falls downslope. Unlike landslides, debris flow does not need water to flow down. In addition, debris flows can be very dangerous. They can move at high speeds, travel long distances, and fill streams valleys up to 100 meters deep with debris. Early warning systems are being developed for use in areas where debris flow risk is especially high. Next type of mass wasting, we have mud flow. Mud flow happens when combined soil and water flow downslope. This usually happens near rivers or streams, where soils or sands are always moist or have been soaked in water for a long time. Its weight indicates the severity of the risk when mud flowed down on a community. In addition to this, a mud flow is a form of mass wasting also, that involving very rapid to extreme rapid surging flow. Commonly, we also refer mud flow in volcanic disaster like lahar flow. Next type of mass wasting, we have the slump. Slumps are also examples of mass wasting. This is a slow downslope movement of loosely consolidated material or rock and soil layers. In time, the area would look curved because of the depression formed by the downslope movement of the soil or the land. In addition, a slump is a form of mass wasting that occurs when a coherent mass of loosely consolidated material or a rock layer moves a short distance down slope. Is a slump fast or slow? They can cover sections of highway with debris. Like other types of mass movement, slumps can be triggered by heavy rain. The slowest form of mass movement of soil or debris is a creep, another type of a slump. A slump also can be triggered by an earthquake, most especially a magnitude 8 earthquake. Next type of exogenous processes, we have the sedimentation. Sedimentation is the accumulation of materials such as soil, rock fragments, and soil particles settling at the bottom. This usually occurs in stream and sea erosion. Over time, the sediment load becomes thick and forms a new layer of a ground. In some small inland waters, the sediment layer will eventually dry up the water and become part of the soil in its environment. In oceans, the sediment layer can form the ocean basins. Ocean basins also change their shape and sizes due to continuous geologic cycle. The change depends on the rate of erosion in their surrounding continental masses or by ocean ridges. Sedimentation processes are an integral part of environmental system and are treated separately from all other environmental processes only because they are linked with the formation of sediments. Sediment is important because it often enriches the soil with nutrients. Areas rich in sediments are often also rich in biodiversity. Sedimentary soil is usually better for farming. Sedimentation process is usually associated with the three sequential stages of weathering: transportation and deposition. Weathering continues during the transport stage, which itself is usually a series of transport, deposition, erosion stages following each other many times. Sediment transportation. The simplest definition of sediment transport is the transport of granular particles by fluids. The main agents by which sedimentary materials are moved include gravity, or what we call this the gravity transport, river and stream flow, ice, wind, estuarine and ocean currents. Running water and wind are the most widespread transporting agents. In both cases, three mechanisms operate, although the particle size of the transported material is very different owing to the difference in density and viscosity of air and water. So in sediment transportation, weathering causes the rocks to break down. Erosion with water and transport moves the sediments downhill to another place. Sediment transport is applied to solve many environmental and geological problems. Measuring or quantifying sediment transport or erosion is therefore important for coastal places. Movement of sediment is important in providing habitat for fish and other organisms in rivers and oceans. The water is stored in a large reservoir, for example, a river or ocean. This slows down the flow of the water and allows large insoluble particles to settle to the bottom. The cleaner water at the top can then be extracted for the next stage. So therefore, we can say that sedimentation plays a big role in water purification. Then we can have a potable water supply, most especially if we preserve our water resources in a cleaner environment. So in your module 1, we have a pre-test. So all you have to do is to encircle the letter of the correct answer. That is item 1 to 10 related to our module 1 topic, exogenous processes. Thank you for viewing my presentation.